Good day, ladies and gentlemen. This is Sarah van Grenne, aka Mr. VG, and I am now neck deep into this question paper 1 of the Department of Basic Education, the 2020 exam paper. And in this specific video, we are going to look at linear sequences. Remember that there are 3 basic type of sequences that we can look at in grade 11: linear, quadratic, and exponential. Now, most of the time, exponential we don't really look at, but in this series of videos about sequences, we are going to specifically focus on linears and quadratics. Exponentials is going to play a big role in grade 12. So let's have a look at this specific sum. I think that this is one of the best questions I've ever seen asked about linear sequences in a grade 11 paper. So you go and try it yourself, and then you look at the rest of the videos. When I look at this question 3.1, it says that the table below indicates the minimum number of matches required to construct a triangle. So 1 triangle, 3 matches. 2 triangle, 5 matches. How do they do that? Well, by stacking the triangles against one another. So you, in other words, use one match as part of 2 triangles. See what I'm doing? I'm taking the maths and I'm making it visual. Okay, I'm taking the maths and I'm making it visual so you can see what is actually happening. In other words, what's happening with the number of matches? To go from 3 to 5, I'm adding 2. To go from 5 to 7, I'm adding another 2. So in other words, please understand this is very important. I'm still going 1, 2, 3. So my number of triangles is still in not just a linear pattern, but in a consecutive pattern. That is very important. If that 4 wasn't 4, but it was maybe 8 or 12, then we couldn't do what we're doing here. So in other words, to go from 7 to my next number of matches for that triangle, I'm again going to add 2, which gives me the value of A, which is 9. And I'm going to add 2 again to get me to B. Again, please get this. It's the number of triangles that are consecutive which allows me to do this. So next up, ladies and gents, I'm actually going to look at what the question asks. So the question is asking me, first of all, write down the numerical values of A and B, which represents the number of matches for specific number of triangles. So if I look at A, the value for A is 9, and for B, it's 11. Please be careful that they don't catch you out using the number of triangles. So write down a formula that represents the general term of the pattern. Now, this whole video is about linear sequences, okay? Which means, again, ladies and gentlemen, linear sequences, there's a constant first difference. So I'm going to do this in 2 ways. I'm going to do it the way that it's traditionally done, by using the sequence Tn equal An plus B, where A is always the first difference, so that is 2n plus B. Now I need to get a value for B, so I pick one of these sets, and I'm going to pick the set 1 and 3. So the number of triangles, that is n. So I'm going to say 2 times by 1 plus B. But this must add up to 3, the number of matches. I could have chosen this one as well. 2 times 2 plus B must give me 5. But it doesn't matter. This means that B must be 1, because 2 times 1 plus 1 must give me 3. Or you can just subtract 2 on both sides. this means that Tn is 2n plus 1. But I know a lot of you would have teachers that teaches you this is an arithmetic sequence which has a standard equation of a plus n minus 1 times by d. Technically, this is not grade 11 work, okay? But I know a lot of your teachers teach you this so that you have the same way of thinking that's going to go into matric. A is your first term, which is 3, and your common difference is 2. I'm going to distribute the 2 into my brackets. And this then simplified gives me 2n plus 1. Oh, look, same thing. Ladies and gents, please just remember to ask your teacher which one they accept to be true, okay? Let's have a look at questions 3.1.3 and 3.1.4. But remember, you have that Tn is 2n minus 1. So when I look at the first question, 3.1.3, how many matches, so that is Tn that they are looking for, are required to create 100 triangles? So n is 100. So replacing the n with 100 or substituting gives me 199, which means it takes 199 matches to create 100 triangles. Looking at 3.1.4, now they're asking me how many triangles. So in other words, n is the question. How many triangles can be made with 305 matches? So that is Tn. I'm substituting that into my formula. So 305 is equal to 2n minus 1. And now I've got to solve n. This is a linear sum. So in other words, I'm going to add 1 on both sides, 306, and I'm going to divide both sides by 2, which gives me n as being 153. Therefore, in 100, it's going to take, there's going to be 153 triangles can be made using 305 matches. As easy and as simple as that. Let's have a look now, ladies and gents, at the next question, 3.2. This is not a question I've seen being asked often, but it is a question that as a teacher, I actually love to ask because it requires you to know the definition of a linear number pattern. And what is the definition of a linear number pattern? That the first difference must be equal. In other words, if I take the first difference, so taking 2x squared plus 5x plus 2, and I subtract from that 2x squared plus 5x plus 5. Okay, that's the first difference. So that's between the first two terms. If I subtract this, I get negative 3. Again, let me not skip a step. If I distribute this in, I get negative 2x squared minus 5x minus 5. If I then add the like terms, I'm left with negative 3. Let's repeat this process between term 2 and term 3. So I'm going to subtract 2x squared plus 5x plus 2 from 3x squared plus 4x minus 3. If I distribute the negative in, I get negative 2x squared minus 5x minus 2. And if I add the like terms, I'm left with x squared minus 5x minus 5. That is my expressions representing the first terms. Now, how do I solve the rest of it? Well, what is the definition? The definition says that the first differences must be equal. So negative 3 must be equal to x squared minus 5x minus 5. Now I completely forget that I'm busy working with sequences. And I look at what's in front of me. There's a quadratic expression, or quadratic equation rather. So I need to get equal to 0. This is a normal term, a quadratic equation. So I'm going to factorize and get my two values for x. So therefore, if x is 2 or if x is negative 1, then my expression will be a linear number pattern. Wow, beautiful. I've seen this question being asked a lot of times at matric level, but that doesn't mean it can't come up in your grade 11 exam paper. So ladies and gents, I hope you enjoyed this video. Our next video is going to be specifically about quadratic sequences. So have a beautiful and amazing rest of your day. Salane Gatle. Cheers.